Hello everybody, I will start my today another coding practice. In my today's video, I will solve this question, odd even jump. Okay. So in this question, I'm giving an integer array. From some starting index, you can make a series of jumps. The first, third, fifth jumps in the series are called odd numbered jumps. And the second, fourth, sixth jumps in the series are called even numbered jumps. Okay. Note the jumps are numbered, not the indices. Okay. You may jump forward from index I to j in the following way. So during odd number jumps, you jump to the index j such that array index j is larger than I or equal, and array j is the smallest possible value. If there are multiple such indices j, you can only jump to the smallest such index j. Okay, so from in the odd number jumps, I jump from somewhere and I will find the smallest number, which is right hand side of index I, and jump to that index. Okay, and during even number jumps, you jump to the index j such that array I is larger than array j. So I go back or stay the same, and array j is the largest possible value. If there are multiple such indices j, you can only jump to the smallest such index j. Okay, so I will jump to the left hand side or I itself, and that in that index, it must be. I will find the largest number in the right hand side or itself, and I will jump to that index. Okay. Okay. It may be the case that for some index I, there are no legal jumps. I see. It may be the case that some index I, there are no legal jumps. Why is it? I think I can always jump to myself. No. I to j. Sorry, I misunderstood something. So I don't say right hand side or left hand side. I will just take a look at right hand side and numbers which are smaller or larger. Yeah, but smallest or largest. I see. A starting index is good. If starting from the index, you can reach the end of the array. Yeah, by jumping some number of times, possibly 0 or more than once. Okay. Return the number of good starting indices. Okay, I see. So I will clarify the question statement first. So my input would be array, which is the integer list, and I will return integer, which signifies the number of good starting indices. Okay. And array has at least one element, and all the numbers in the array are integer and non-negative. Okay. So let me think with this example. So when I start from here, this is my first jump. So in my first jump, which is the odd number jumps, I will find the larger or equal number and smallest number out of them. So all the numbers are larger, so I find 12, which is larger. So I come here. Then in the second jump, I will look at the number itself or 14, 15. Then I find the largest value, which is 15. So I can jump to here. And that's it. Oh, then we cannot jump anymore. Sorry. So during even number jump, okay, I will jump to the smaller number or equal number. So I can jump to 12 or smaller on the right hand side, and I will jump to the largest number out of it. So I cannot jump. Okay. Now I will think of number 13. Starting in my first jump, I will look for the number which is larger or equal, which is 13 or more. So I find that 14 and 15, and 14 is the smallest one. So I jump to here. Then from here, I look for the number which is smaller than 14, but I cannot find it, so I can't jump anymore. And from 12, I think in my first jump, which is odd numbered, I find 14 and 15, and so I will jump to 14, which is the smallest one. Okay. Then from 14, I look for the number which is smaller or equal, 14 or smaller, but I cannot find, so I can't jump anymore. So when I start from 14, in my first jump, I will look for the number which is larger or equal, so 14 or more, in the right hand side, and which is, and out of them, the smallest one is 15, so I can reach 15. Okay. Then if I start from number 15, yeah, this is the goal itself, so it's okay. Okay, now I've understood the question statement and the jump, how I jump. So let me think. So obviously, the brute force approach for this is start from each node and try to, jump as I'm supposed to be. Then I will see where I can, reach in the end. But it takes, quite a long time because I start from each node. That can be, possible start indexes are n. And from each, for my first jump, I have to take a look at all the remaining numbers and find the next index. Then from next jump, I have to take a look at all the remaining, numbers, and I decide the next jump. So without any optimization, it will take around like this. Yeah. So it quite inefficient. Yeah, algorithm. So I will think how I can do it. Yeah. Obviously, from this, what I can do is building the pre-calculated result of the jump. So I can say when I'm at number 0, the place where I can jump is quite limited. Yeah. So obviously I will jump to, from here. I always jump to order even. That's the point. So when I'm 10, when it's odd or odd jump, I will look for a number which is larger than or equal to 10. And out of them, the smallest one is 12. So this jump to this 12. Okay. And if this is the even jump, I will look for the number which is, smaller or equal, so 10 or smaller. And I will pick the largest one out of them. And I find that there isn't such number. So I cannot jump. Okay, so yeah, what I want to say is for each index and for odd or even jump, where to jump is determined. Yeah, and it can be memorized. Yeah, I think how I can. Yeah, that reminds me of the dynamic programming, because once I find where I reach from a specific index, that can be used. For example, for the more broader problem. So let's say if I'd like to jump from 10, and if jumping from 12 consequence is already determined, I can almost immediately find where I will reach from node 10. Yeah, that's how I use the result of the subprogram. Yeah, and also the results of the subprogram can be memorized. So I'm pretty sure I can use the dynamic programming here. Okay. So okay, I would say for each index and for the next jump is order even. I mean, with that combination, I can find if I can. I mean, the consequence is determined. So this would be my recursive function. Okay, and so the time complexity should be, I mean, at least this function, recursive function, the argument can be n times 2. Yeah. So, for, I mean, the function is called n times, O of n times. And inside of it, I will do a bit of optimization. So the naive approach is that, say, from 13, I will take a look at all the, later numbers and find the 13 or more, but smallest one in the case of odd jump. But if I do the kind of suffix max array, I can, no, I don't say suffix max, but I think I can definitely use sorted list. Yeah, to find out the number which is larger or equal but the smallest in the log n time. So in naively, if I take a look at each number to decide the next jump, it will take all of n time. But if I use sorted set, I can find it in all log n time. Or I think I can use the segment tree instead of the sorted set. In that case, it would also take all of log n time. Okay, so let me start the implementation with sorted set. Yeah, implementation. Wait, but if I'd like to use the sorted set, do I initiate the sorted set for each, I see. So the key here is that I will take a look from the tail. So in that way, I know that 14 will end with 14 is good or not. And also good thing is that I build the sorted set one by reversely going backward. So say when I reach 12, yeah, when I reach 12, I will take a look at the sorted set and find out which index to jump. It's good. And after that, I will insert this 12 to sorted set, and then I will take a look at 13. And from 13, I can know where I can jump. And also, you know, I know, yeah, if this is, I mean, um, yeah, I can know where to jump from 13 with by taking a look at the sorted set. Yeah, that's it. Wait, but the one problem is that I said from 13 I can say where to jump, but it totally depends where, you know, if this is the next is odd jump or even jump. So I have to think of two cases. Okay, so now what I'm thinking is that I will first okay, I will separate two works. The first work is I will decide where I can jump from, you know, each node. So my first task is to completely prepare this. Then I will, yeah, call this with an start index. Yeah. Okay, so this is how I can do it. Okay. So let me make it a hash map. Okay, now that being said, I will start the implementation. Oh, so no. Basically, I start from each index. Okay, this is how it works. So in line 30, I build the next indexes. So this is used as, inside of the is good recursive function. Okay. And in line 37, I initiated the good count, which should be updated inside of the recursive function and eventually returned. So in line 38 in the for loop, I will start from each index and see if it is a good index or not. Because I start from that index, next or jump is always true. Yeah. Then I increment good count if it is good. Yeah. Then in line 41, good count is returned. Okay. So now I will, does implementation of the two sub methods. I start with is good. So this is a base case. I guess the next index and yep, this is it. Okay. Now I will implement the next indexes. Build next indexes method. Okay. So as I said, I start in a reverse order. So I have a sorted set, no, sorted list, and okay. Okay, so for example, if I'm out here, what I will do is I will, okay. Um, I I will have to do two things. The first thing is for odd jump and also for even jump. I will find num, which is larger than or equal to nums I. Okay, and I want this. And also for even jump, I will find the largest x, which means x is smaller than or equal to nums I. That's what it means. Okay. So for this, I use the sorted set, and let's assume I current number is 10, and I have 8, 9, 9, 10, 10, 11, 12 in the list, in the sorted set. No, sorted list. So in this case, what I want is, oh, and also it has to be the youngest one. I mean, youngest index. So let's say 10. Because this is sorted list, it works in this way. Yeah, it's sorted. Good. I don't know. Something like this. So in this case, what I want is this index. I will take a look at this and I get this index. So how we can get this index? So I can get it in this way. Sorted set of I will take a look at past nums, and what I want is the youngest index. So I use the bisect left. So in this way, I will find the index which is equal or larger than this, the target, and the target should be nums I and minus infinity. Okay, so in this way, I can find the index. But one thing I have to take care is, if next index is equal to the ranks of the sorted set, this means that there isn't any jump. Yeah. So I have to just make sure that if this is smaller than this, I can jump. So I will append it to the next indexes. Let me call it return. So this is for auto jump. This should be next index. Okay. So what I've forgot to do here is that I've just noticed is that in line 38, I have to check if this exists in the next index or not. Okay. Now I come back to line 69. What I will do is basically the same, but I have to get the next time largest x, which means smaller than num. Okay. I actually cannot use the same sorted set with this, because in this case, the index is sorted. Yeah, in an ascending order, just like value, num is sorted in ascending order. This works, but if, yeah, I try to use this for the even jump next indexes, what happens is that, for example, this, I want number, which is, larger than equal to nums. So let's say this is 10. I want this and this. But, oh no. Okay, so let's say I'm looking for number 13 and I have this and this. In this case, the problem is I'm looking for 13 and then I can find this one just before 13. But the problem is what I want is 12 2, which is smaller one. So, I mean, this doesn't work. I have to make num and index in a reversed ascending or descending order. So I will separate the sorted set for this and this. Okay, so maybe I can separate the method, but let me go with this. Yeah, so in my second sort, I will separate them. Okay. Then I use the union for this. Wait, is there a union? Oh, sorry, I'm not pretty sure. So let me change my mind. I initiate the next index here. And this, I rename this from build to append or insert. Okay. Then I will update array. No, next indexes. Yeah. Okay. So instead of read, I add a new number to give him next indexes. Hash map. Okay. So now I will implement this insert even next indexes. And in this case, I will make just one, change. So I basically reverse it with minus num. So in this way, it should be like this. And now it is sorted in that. In this order. Okay. So say when I'm looking for 12, I will take a look at minus 12. Okay, so if the current number is 12, I try to find the largest x. So it should be negative 13 or negative 14 is better, but it should be the largest. So in the negative world, it should be the smallest. Yeah. So what I'm looking for is, wait, this is quite confusing, but if my current value is 12, I'm looking for 12 or larger. So it should be this or later. Yeah. Okay. Then, no, sorry, which means x, which is smaller than or equal to num. So right. So if I have 12, I will take a minus 12 or larger. No, 12 or smaller. So in a negative word, 12 or greater. Yeah. Then I want the youngest index in, yeah. In the case if there are multiple 12s, I want the youngest index, so I can find it in this way. Okay. So as I said, I append negative to num. Oh, one thing I forgot to do is in line 67, I have to append the current number into the past nums. Like this. Okay. And I come back to line 78. So I use the bisect left, and I use minus nums I and minus my infinity. Next index, I get it. And if there is, wait, if I'm negative 12, or I say if I'm 12, oh, sorry, this, yeah, for even jump, sorry, I'm looking for a number which is smaller. So I want to jump 10 or something. Yeah. And for the odd jump, I'd like to jump to the number which is larger, but smallest. Yeah. Okay, so what I'd like to jump is, for even jump, the smaller one. Oh, sorry, the problem here is that this is actually not sorted in ascending order. This is now descending, so that's a problem. Hmm? No, this is now ascending. Yes. Oh, these are ascending. Sorry, but this is not. Yeah. Yeah. And that being said, if I'm looking for 12, if current number is 12, I'm looking for the number which is smaller. So like 11 or 10 or 12. So I can start from taking a look from here, then start the youngest index. I mean, if there are multiple element in the start, which is the same number as the start number. Okay, good. So basically, I use the bisect left in the same way. And I guess the next index. Oh, and this should be false because I'm thinking of the even jump. Then, in the end, I update the past nums. Sorted set with this. Okay, implementation is done. Um, let me excuse my code. Okay, this should be array. Good. Okay, so I updated it. Oh, I don't need. Oh, sorry. Index and next is odd. Next is odd is the hash map. I need no. Ah, okay. So here I have to reverse. Next is odd because in the next jump it should be even if current is odd. Okay, so seems like I think I'm not jumping to the forward, maybe, as because it's now infinite loop. Yeah, right. From 3, I'm jumping to index 0. I see. I understood what's the problem with this. So here, um, oh no, wait. So from 3, it's becoming backward, 2 going backward, and 0 through, no, 2 fourths, yes, 1 fourth, no, 2 fourths, no. Ah, I understood. Okay. So here in running 65, this is not the next index. So I can say, let's say this is index X for now. In that way, the index should be taken in this way. Yeah. So I record this part first, large greater than or equal index. Same here, like this. Okay. No, here it should be like this. I get the first greater or equal index, and then I put it here. Then I get it here. Okay. Good, accepted. Okay. Now I comment out the print statement and I submit my code again. Good, accepted. Okay. So I will quickly do the complete analysis, even though I already said this. So for time complexity, it should be okay. So first 3, I initiated the next indexes. Yeah. And this takes n log n because I started from each, oh no, I traverse the index I traverse the the array in a reversed way for each of insert all. Okay, everything for insert all the next indexes. I traverse the array in a reversed order one by one from tail. So there were n steps, and for each step, I used the sorted set, and I got the bisect right here. Basically, bisect ref takes all of log n time. Yeah, assuming that the number of elements in the sorted set is n. So, in a single step, in the worst case, it takes log n time. So, in total, it should be n log n time. Okay, and the same for the insert even next indexes. So currently, the time complexity is n log n, and in line 48, I call the recursive function is good. And as I said before, is good is called at max 2n times. Yeah, I should say the argument of is good recursive function is 2n because index can be 0 to n minus 1, and next is odd is true or false. So in total 2n. And once it is calculated, this method is returned. This method returns the result in the constant time. So I just use and inside of this is good method. All of the operations, aside from calling another recursive function, is constant time. So yeah, the time complexity for overall is 2n times 1, which is 2n. So the time complexity is in total n log n. Okay. And for space complexity, this should be n, because sorted set, this is a kind of, actually a kind of tree structured, even though internally it uses array, I guess, like the heap. Yeah. So the space complexity would be O of n, which is the maximum number of elements when the traversal is ended. And aside from that, I use recursion stack. And yeah, recursion can be up to n lengths because in every step I go forward. Yeah, it never stays the same index. Yeah, it has to go forward. So in the worst case, in each recursive function, the index is moved by one by one. So in the recursion stack is max length n. So the space complexity is O of n. Okay. So I quickly wrap up on today's coding practice. So today I said the question odd even jump, and in this question, I omit the question explanation, but I basically use the idea of dynamic programming. Yeah. So is good is the dynamic programming recursive function interface. And inside of this, I had to find which index it can jump from the current index. And to find out that, I pre-calculated that result with the sorted set. So in that way, I could, optimize the time complexity from n squared to n log n. Okay, so that's pretty much it. Thank you so much. Bye.